can you please get ready with a browser and a calculator, because we're going to need a calculator. If you have a calculator on your phone, please have it ready, because we are going to do some simple math. Nothing big, nothing honors type of math. It's just multiplication and division. In the meantime, I'd like you guys to go to a browser, and you're going to go to joinpd.com. We're going to use the Peardeck today, so I can record your participation answers, especially for the math part. Okay, so 1 second, let me start my presentation. So once again, please go to Join PD. Let me type it in the chat of what, and so we're gonna answer that question that was on the slide. All right, anyone else who's having trouble connecting to the Join PD, let me know, because if you are, then you can follow along with the screen that I have, because what's gonna happen is all you need from Zoom is my voice, and then the browser is the one in front of you, because that's where the slides are, and then that's where you're also gonna answer, okay? All right, let's join class code. Okay, let's answer, because some of you guys already started answering. How does this demonstration apply to Newton's second law of motion? So how did, according to Newton's second law of motion from our notes last time, an object that is accelerating and has a certain mass is equal to the force applied to the object. So in this particular scenario, how did he demonstrate Newton's second law of motion? So let's take a look at some of you guys' answer. Go ahead and answer. I got 13 out of 21 responses already. I'm still waiting for 7 more people. Okay, and if you guys don't know, I can see who's answering and who's not, and who's typing and who is not. Okay, so
how do you submit the answer? I don't see a submit button.
It just submits automatically once you type in.
You push enter?
Yeah, you can hit enter. It's the same. And let's take a look. So while some are still answering. So here are some answers. When something more mass has the same force applied on it from a smaller mass, it goes slower, less further. All right, so that's from Connor. Thanks, Connor. Let's have another one. It applies to Newton's second law of motion because it shows the mass affects the acceleration. That is from Massa. That's correct also. That's right. According to Newton's second law of motion, given a fixed amount of force, meaning the force applied in the bungee cord from the example that we saw, the acceleration of the object depends on how heavy the object is. The second law of motion is also called law of acceleration, and acceleration is just a simple change in speed or direction in terms of like speeding up or slowing down or changing direction. And here are some examples. Going downhill the roller coaster is an example of acceleration, or when you go to uphill on the roller coaster, that is another example of acceleration. Or when you're turning a corner, even if the speed of the roller coaster is the same, it is still considered as an example of acceleration. So I would like you to think of one instance or one example that you think shows a change in speed or direction, or it shows acceleration. So remember, acceleration is not just speeding up, but it's also slowing down or making a turn. So go ahead and write that down. I'll give you guys about 1 to 2 minutes to write down your thoughts, and we are gonna continue in a minute. All right, let's take a look at some of you guys' answer. Okay, Peyton mentioned about the game badminton. That's right. And then Lily says cars going down a hill. Yes, it's kind of like the same concept as a roller coaster. We already have been talking about the Manta, the electric eel, or whatever rides we have, the brakes and wheels on a car. So Des, if you can describe how it actually changes its acceleration, just modify your answer on that. So according to Newton, he said that the acceleration depends on 2 things. First, the net force, meaning the force you apply to the object, and the mass of the object, okay? And therefore, if you change the mass of the object, the force that you need to apply to the object has to change as well, right? In order for you to get the same acceleration, right? And that's what Newton was trying to tell us. Or if, let's say, for example, the amount of force you're exerting is always the same, then if you increase the mass, then it becomes slower. So that's their relationship. That makes this triangle formula came about. In order for you to represent that thought, math has that way of representing, in this case, by using division and multiplication. So whichever that is, we're going to learn how to use this triangle formula, okay? So acceleration is normally produced when the force acts on a mass. We already know that. The only time that object will move is when we apply force, right? And the greater the mass of the object being accelerated, the greater the mass, the force that you need to use in order for that object to move. So let's say, for example, a grocery cart that's empty, you try to exert a force on a grocery cart. It's easier compared to if you have a full load of grocery cart, right? So you exert more force on a heavier cart than the lighter one. So that's what Newton's trying to say. So let's learn how to use this triangle, all right? Because you can actually determine or find the force, the mass, and the acceleration using this triangle. So let's start first by, what if we are looking for the force you need to move an object? So that is your letter F at the top. So your F at the top, we cover it with our hands. So use your hands and cover the top, right? And we are left with two other letters, the M and the A, right? The mass and the acceleration. So what operation is in between the mass and the acceleration? What math operation is in there? In between the mass and... Correct. That's right. So that's why if we are looking for force, meaning we cover up the force because that's the one missing, we can get the force by multiplying the mass and the acceleration of the object. So that is 1. Now, let's cover the side of letter M, or the mass. So if we're looking for mass in our triangle, we're going to cover M. And so between F and A, what is the math operation between F and A to find the mass? Anybody? So cover up.
Division.
Yes, we divide F, or force, by acceleration. So F divided by A is when we find the mass of the object. So if we're trying to find, oh, I don't know how heavy this object is, and I exerted this kind of force to move it, but we don't know what the mass is, then we can divide the force and the acceleration. And lastly, if you're looking for acceleration, cover the A. And this time, when you cover the A, how are we going to find the acceleration? What is the operation between F and M? We are going to
Divide?
also divide. Yes, divide force by mass so you can get acceleration. Well, let's practice though, just to apply this triangle for us. So in this problem, here's a scenario. Someone kicked the soccer ball, and that soccer ball has a mass of 0.42 kilograms. And it starts moving at an acceleration of 25 meters per second squared. What was the force? So my first question is, what are we looking for? Okay, so just write down number 1, what are we looking for? Just write down your answer. And number 2, how do you find the force? So according to our triangle formula, how do we find the force? What are we multiplying? Okay, if you wrote that down by multiplying what are we trying to multiply? And then you show your solution, and then of course, what's your answer? This is where your calculator is important right now. So bring out your calculator and let us answer. I see a lot of right answers. That's right, Jewel. We are looking for force. And according to our triangle, if we're looking for force, we have to cover up the force, or F, right? And that leaves us with two letters, the M and the A. And in between the M and the A, what operation here? Evelyn says multiply. So our mass is 0.42, right? And our acceleration is 25. And therefore, if we use our handy dandy calculator, we should get, what's our answer?
10.5.
Yes, that's right, Clara. It's 10.5. And if you have not, if I didn't tell you, force, its unit of measurement is N or Newton. Okay, unit of measurement for force is Newton. Force. In order to get this, we multiply. And what are we multiplying? We're multiplying the mass of the object by the acceleration of the object. So this is an example of Peyton answered this. That is correct. 10.5 Newton. Okay, let's try another example. And this time we're going to look for, so this is the answer for that. This time we're going to take a look at another problem. So here's another problem. Let's try another example. So a force of 20 Newton acts upon a 5 kilogram block. Calculate the acceleration of the object. Let's take a look at this one this time. So first, what are we looking for? Now, once you already identify what are we looking for, you got to cover that up in your triangle formula so that you would know how you find it, right? And then once you know how to find it, then use the numbers given to you. What are you going to do with the numbers? Throw it out and answer. But first, let's see who knows. What are we looking for here this time?
The acceleration.
Yes, acceleration or A. All right, let's see our answers. We got 17 out of 22 people who've already answered. And some of you are zoning out, going somewhere else probably. Chase, Connor, Sirius, and Devin, you guys don't have any answers yet. All right, let's take a look at our answers. Let's see, this time we are gonna highlight, we are looking for the acceleration. We find it by dividing the force by the mass. And that is from Julian. It's 20 divided by 5. So the answer is 4 meters per second squared. Let's have one more. This time I'm gonna have you choose, okay? A 5 kilogram bowling ball is rolling at a frictionless surface and is accelerating at 2 meters per second squared. How much force is applied to move this object at this rate? So in our triangle, remember, we are going to cover up what's missing. And in this case, what are we missing? What are we missing this time for this problem?
The force.
Let's see. I think we can squeeze in one more because we haven't found the mass yet. Let's see what the answers are. And the answer is, that is right, 10 Newton. A bicycle with an unknown mass is moving at 0.3 meters per second squared. If the force applied to the bike is 24 Newton, what is the mass of the bike? Or how heavy is the bike? If it's moving at 0.3 meters per second squared and 24 Newton. So which one is the answer? Is it 30, 80, or 120 kilograms? Here is our poll. The answer is 80 kilograms. So all you need to do is how do we find the mass here? Divide what with what? Divide? Yes, that's right, Lily. It's F divided by the A.